A baseball thrown in the air follows a smooth parabolic path. A baseball bat thrown in the air doesn't. The bat wobbles around a special point. This point stays on a parabolic path even though the rest of the bat doesn't. The motion of the bat is the sum of two motions, a spin around this point and a movement through the air as if the mass were all concentrated at this point. This point, called the center of mass, is where all the mass of an object can be considered to be concentrated. The centers of mass of the baseball and the spinning baseball bat each follow parabolic paths. For a symmetrical object such as a baseball, the center of mass is at the geometric center of the object. For an irregularly shaped object such as a baseball bat, the center of mass is toward the heavier end. The center of mass for each of these objects is shown by the red dot. Objects not made of the same material throughout may have the center of mass quite far from the geometric center. Consider a hollow ball filled half with lead. The center of mass would be located somewhere within the lead part. As an object slides across the surface, its center of mass follows a straight line path. The center of mass of the rotating wrench follows a straight line path as it slides across the smooth surface. The motion of the wrench is a combination of straight line motion of its center of mass and rotation around its center of mass. Internal forces during the explosion of a projectile don't change the projectile's center of mass. The center of mass of the fireworks rocket and its fragments move along the same path before and after the explosion. Center of mass is often called center of gravity, the average position of all the particles of weight that make up an object. For almost all objects on and near Earth, these terms are interchangeable. There can be a small difference between the center of gravity and center of mass when an object is large enough for gravity to vary from one part to another. The center of gravity of the Sears Tower in Chicago is about 1 millimeter below its center of mass because the lower stories are pulled a little more strongly by Earth's gravity than the upper stories. The Sun itself wobbles off-center. Astronomers look for similar wobbles in nearby stars. The wobble is an indication of a star with a planetary system. If all the planets were lined up on one side of the Sun, the center of gravity of the solar system would lie outside the Sun. The center of gravity of a uniform object is at the midpoint, its geometric center. The CG is the balance point. Supporting that single point supports the whole object. The weight of the entire stick behaves as if it were concentrated at its center. The small vectors represent the force of gravity along the meter stick, which combine into a resultant force that acts at the CG. If you suspend any object at a single point, the CG of the object will hang directly below the point of suspension. The CG of an object may be located where there is no actual material. The CG of a ring lies at the geometric center where no matter exists. The same holds true for a hollow sphere such as a basketball. There's no material at the CG of these objects. The block topples when the CG extends beyond its support base. This Londoner double-decker bus is undergoing a tilt test. So much of the weight of the vehicle is in the lower part of the bus that it can be tilted 28 degrees without toppling. The Leaning Tower of Pisa doesn't topple because its CG doesn't extend beyond its base. A vertical line below the CG falls inside the base, and so the Leaning Tower has stood for centuries. The support base of an object doesn't have to be solid. The shaded area bounded by the bottom of the chair legs defines the support base of the chair. Try balancing a broom upright on the palm of your hand. The support base is very small and relatively far beneath the CG, so it's difficult to maintain balance for very long. After some practice, you can do it if you learn to make slight movements of your hand to exactly respond to variations in balance.